Hey everyone. So here's a quick summary of our discussion of inference with random sampling. So just to reiterate, we're talking about cases where we're taking random samples from a large population. We want to know something about that, some parameter about that of that population. We want to make inferences about that population parameter, but it's not directly observable. And we use, for example, the average or the mean of our sample to make inferences about that unobservable population average. Okay, the example that we used in our previous couple of videos was Trump support in the 2016 election. It's not prior to the election, it's not directly observable in the population, and we're trying to make inferences about that, the parameter that we can't observe based on our sample and the estimator that we're using with the data that we can observe. Okay. We can, based on large sample theorems, we can characterize how good our estimators are. For example, the sample average, how good of an estimator that is for the sample population. And we're using two key results from probability theory. First, the law of large numbers, which tells us that our sample average approaches the expectation of the random variable in the population. So the larger our sample, the closer and closer we actually get to the true value. And we're using the central limit theorem, which tells us that the distribution of x bars across repeated sampling approaches a normal or follows a normal distribution with an average of the expected value of x and our variance that is given by the variance of x divided by the sample size. Okay, and this again holds for large samples, which is why we're talking about asymptotic inference, right? Large sample, these are large sample properties. Okay. Based on that, we can compute the standard error, which is just the standard deviation of our sampling distribution, which is the variance in x in our random variable divided by the sample size. And we'll take the square root of that to compute the standard error. And based on the standard error and our x bar, we can then compute the confidence intervals. And we said for the 95% confidence interval, our critical value is 1.96. And so the confidence interval around our point estimate x bar is x bar minus 1.96 times the standard error and x bar plus 1.96 times the standard error. Okay, that's how we compute the confidence intervals. Okay. All right, that's it for the quick summary. In our next video, or next couple of videos, I'm going to talk about estimation and uncertainty in experiments.